Earthbending. Best known from the series Avatar: The Last Airbender, it is a geokinetic force that allows the user to control the motion of rock, some metals, and even lava. Based on the Hung Gar martial art, the user must have a firm connection to the ground so as not to lose their stance. But does their stance really keep them from losing their grip on the ground? Physics says otherwise. Today, we will be observing the impact of physics in earthbending and how animation makes it possible for the user. I do want to add the disclaimer that most of the calculations I have made are based on the visual aspect, and trying to measure things that have been animated obviously has its downsides. I've tried to make them as best as possible, so bear with me. When we imagine earthbenders, we see these muscular dudes who can move mountains with ease. But the fan favorite and most important earthbender of all is a little girl by the name of Toph Beifong. Though she is blind by birth, she uses her disability to her advantage. Her power is the use of seismic sense, or the ability to sense movements in the earth around her, even if it is not connected to the ground. This allows her to have quick reaction times. Though Toph may be a force to be reckoned with, she is not immune to physics, and in the real world, someone her size would likely kill themselves with their own power. Here's why. In the episode entitled The Blind Bandit, we see Toph take on a number of earthbenders at a time. But the part where we are interested is when she uses a rock shield against Shin Fu. After she creates the shield, she launches one side at her opponent. This side is seen flying across the ground towards Shin Fu, who quickly dodges it. Using work energy theorem, I was able to calculate a rough number for the amount of force she had to exert on the shield to make it fly like that. I'm going to show you the full clip and then do a still to show you where I made my calculations. This is the part that I was talking about where this little girl is able to essentially launch this big hunk of rock at a dude that's probably twice her size. And personally, I think that's amazing. But on with the calculations. Starting with the mass of the rock. Different types of rocks have a wide array of densities from which to choose, but since I was unsure of the exact material, I used the density of limestone in my calculations, which is 2.7 grams per cubic centimeter. Now, from a wiki page, I was able to find Toph's height as 1.13 meters, including the size of her hair. I shortened this to 1 meter to accurately represent her true height. And using a ruler on my computer screen, I created the scale of 4.5 centimeters as 1 meter. I was able to find the volume of the half of the rock shield to be 0.091 cubic meters. Using the density of limestone in the volume, I calculated the mass to be about 245.7 kilograms, which is around 542 pounds. Now here came the tough part. Because it is animation, I assumed the rock reached its max speed instantaneously, so the distance over which the force acts is going to be small. For my calculation, I used 0.01 meters, and since it is not on the ground, I neglected the force of friction. From this, I estimated that the rock had a speed of 2.6 meters per second, which is double the normal walking speed of a person. I came to this conclusion because the rock seems to cover about 1.3 meters, according to the previous scale, in nearly half a second. And for this to be possible, Toph would have had to exert a force of roughly 83,047 newtons over the distance of a centimeter. And considering her size, this is quite a feat. Like, this girl's been working out. Now let's think about the physical consequence here. According to Newton's third law, forces act in pairs. So whatever Toph exerted on the rock affects her the same way. All 83,047 newtons of it. I wanted to find the speed that she would fly back from the rock if friction was not present, or if this happened in the air where she could not root herself to the ground. I was able to find a source that said she was about 90 pounds, which translates to about 41 kilograms. Using the idea of impulse, where the time of impact is 0.1 seconds, and the force applied is negative 83,047 newtons because force is a vector, Toph will be flung back at a speed of 20.3 meters per second, or about 45 miles an hour. So she's basically street legal. But the scene doesn't show Toph being flung back at the speed of a normal streetcar. No, she's standing still. So let's think about the amount of friction that must be present. Since Toph is standing still after the collision, the force of friction must balance out with the force exerted on her. In this case, the normal force would be equivalent to her weight. And using Newton's second law to solve for the coefficient of static friction, we would end with a value of 207. For comparison, the coefficient of static friction for rubber on rubber is 1.16. So she's like industrially rooted to the ground, like Gorilla Glue has nothing on Toph Beifong. In conclusion, Toph is cool, but without the world of Avatar, she'd honestly be dead. And if we look at this situation through the lens of conservation and momentum, earthbending is an obvious violation. If we considered the magnitude of force it takes to break human bone, Toph would break her hands along with the rest of her body every time she bends. So there must be something about earthbending that not only allows people to move large hunks of rock, but it must also protect the user. One could likely describe it as a type of force multiplier. And though this would have to be true for the real world, the world of animation lets Toph make it look easy.